Okay, well, next part of this series is going to be on effects, send, and return. So, let me kind of look at this. Usually I've seen it like right before the last amplification stage, but I honestly would like to have effects loop on the clean and distorted channels, but I think at least the one I've looked at, they usually kind of go before the final amplification stage. I can't say that for all of them. I don't really look that much, but it makes the most sense to me. So at least in my preamp, you've got either clean channel selection or the distorted channel, goes into a buffer, effects loop, and into an amplifier. So let's just talk about the effects loops a little bit, and I'll just tell you, my experience with them. This is, bear with me here, this is actually the same circuit in a different program, Easy EDA. It's awesome, and they make it downloadable now. So it used to be only online, but now you can totally have this offline if you're ever scared that you'll relying on somebody else to store them, cloud storage, whatever. So you just have to disregard some of my notes in here, but you can see here's and again, these are personal notes, so just ignore them. But here's your emitter follower. It's going into effects, send, and return. It's actually kind of simple, but it could be. There's different ways to do it, so it's not always simple. But I'll show you the way I did it, and I'll kind of talk about a little bit other things to think about when you build effects, send, and return. First of all, you got to think of this pull down resistors, keep things at ground, and you need to think, well, what input impedance am I going into when I leave the effects send, and when I come back, what am I going to see in terms of the effects return input impedance. So these are kind of things to think about. It's not, well, the first thing I'll say is effects send, usually the effects send is kind of lower input impedance, but not always, because sometimes people just don't put the circuitry in to bring it down. I think in my experience it's usually kind of low, maybe 1K or less. The output level is usually like, in my experience, like 300 millivolts or something like that. 325 millivolts RMS is sort of like a nominal value, I guess they would call it. And the return is different. Like you would think, or at least I would think, if you're returning into something, then it ought to have a pretty high impedance input. But a lot of times they don't. Like I think my guitar preamp, or my guitar amp, not the one I built, but just one commercial one I bought, is I think the effects return is 22K on that. I've seen it 10K, 33K, 47K. So basically, when you're designing the preamp, that's something you'd want to consider. In mine, it's going to be like, just eyeballing this, I think it's probably at least 47K. And we'll talk about that when you're going into the next amplifier stage. But I'm going into this amplifier stage afterwards. So basically, if you look at these jacks, you usually use, and you can configure this different ways. I'm going to show you the way I've configured it, and I'll tell you why I do it that way. First of all, you've got a switched jack. So you've got the tip and the switch and the ground. Same here, tip, switch, and ground. And there's different ways to wire this, but the way I do it is I've got the tip going out to the send, and then I also have that same exact signal, the tip, going into this amplifier. So if I plug something into the send, I can send that low-level signal off to something even if I don't return it, and this signal should pass through okay. So that's how a lot of people do it. You don't have to do it that way. Now, in the past, what I would do is I would have it switch so you have to have them both plugged in for the signal to even come through. There's different ways to do it. Sometimes people will have it switch so whenever, like this, you can connect up to the switch so that when you plug this in, it totally cuts off the signal to your circuit. And the only way to get that signal back is to return it through here. But I find it this way is nicer because I think sometimes you're in a situation where you're powering a power amp, but you might want to take that signal off for, recording or doing something with it and at a lower level, so it just comes out this way. Now, what happens when you return it and you plug this in is it disconnects this switch from the tip there, and the signal no longer goes through, but the return signal does. So basically you send it off to some effects unit and it comes back, and then this is totally disconnected when you plug this back in, and so you've got that nice effects loop coming through. I used to do it where I would switch both of them, but I found, honestly, from a practical standpoint, that I want to use these tip switch configurations as little as possible, because I found that they fail so often. And that's not, like, you might not think of that if you're just building this circuit. Well, I think it's better to wire it this way, I think it's better to wire it that way. Well, in my opinion, I think it's better to use these switches on the tips as least as possible, because I've had them fail so frequently. And so with this configuration, I only have to rely, as far as the switch tip connection, I only have to rely on one single one. And that's enough for me because, like I said, they fail a lot. I think that's, you can just maybe look this up on your own if you want to learn more about it. Like I said, there's different ways to do it, but this way I think is fine. You have to think about the input impedance coming back in. You got to know sort of what impedance you're going out to, of course. And the reason that that's important is you have an output, source impedance right here. And so you got to make sure that's low enough. I have mine at like 1K, so that's good enough, but it's not good enough for like low impedance applications. So you might need something a little different. And make note of these PDR. That's pull down resistor, and I've kind of got one right here too. And that's something to think about. Another thing to think about are these capacitors, because like this capacitor is expecting probably a 10K or more, really more than that, probably like 50K or 100K, because you want to, I'm using one here because it's sort of, how should I say it, I'm expecting the load to be more than 10K on mostly anything I would be plugging this into. I mean, if it's a pedal or effects unit or something, it's usually going to be 100K or more. So I just kind of use this in here, and I don't, I try to not go above 10 microfarads at all if I can help it, just because just because of the cost, and I don't like using electrolytic capacitors that much. So hopefully this is enough talking about the effect send and return. I think that's about all there is to it. You just have to think about like unknowns, because you just don't know like what you're going into. So you've got to plan for a big enough capacitor to make sure that's the case. You don't know the output impedance of what's going to be coming in through here, so you have to make sure you have enough input. I mean, you can just buffer each side if you want, but I found a lot of circuits don't do that. They just kind of figure you're on your own, but just if you need a buffer, use external buffer or something. But so I think that's probably enough on this. I guess I'll mention, I have this preamp. Maybe I'll just show that to you. See there. See if it even comes up. But I've got sort of a nice preamp I'm working on. And I probably will make this available if anybody wants to buy it. This is my own personal one, but I kind of wouldn't mind making it into a kit or something like that. I'll talk more about that later, but yeah, close out of this. Alright, well, see, next, I think probably about the last thing, maybe one or two more things, is we'll talk about this amplification next. And this may go a little long just because I think amps could use a good talking about, especially the biasing and all that with them, but we'll see. Well, thank you for watching.